let us have fun with question 4. We are told in question 4 that consider a chain of reactions below. So they're telling us here that it's a chain of reactions. And we can see that this is a chain because we move from this molecule to that molecule. So this is part of the reactants and this is the product. Then, this is the reaction A, you can see. Then we take the reaction A further to go to reaction B, through a reaction B, to take this as a product now. What used to be a product, we're taking it now to be a reactant to form this new product. So it's a chain because we move from one reaction to another reaction, B, A to B. Now, when we look at these reactions, it's very important to try to interpret them. I can see that this reactant here, what I can call reactant, is almost the same as this product here. The only difference is that we have a bromine on this one, and here we don't have. And that tells me that in this reaction, they've actually added a bromine as part of the reaction. They added this as part of the reactants, I mean to say, because it's now appearing here. And that type of a reaction, we know that it is actually a hydrohalogenation reaction because we're actually adding a halogen here. That's why we call it a hydrohalogenation. And we normally add this halogen in a molecule that is an alkene, meaning that has a double bond. And I can see here that I have a double bond because normally at the end we should have 3 hydrogens here and 2 carbons, 2 hydrogens on the C here, but we actually have 2 and 1. Though that tells me that 1 hydrogen and 1 hydrogen here, they actually form the second bond and we have double bonds there. But when we come this side, you can actually see that we now have 3 hydrogens and we have a hydrogen and a bromine. So that means we are actually now forming 2 bonds here, the Br and the H. And then here we have those 3 bonds, the H and the H. As I was saying, here it's only 2. So I'm going to have only 2 here. And that means I'm going to have 1. And that should mean there was a double bond there. So this, for me, it's a very, very straightforward hydrohalogenation reaction where we're actually adding the halogen, and in this case, they use a bromine because remember, our halogens include chlorine, bromine, fluorine, and iodine. Then when we look at this reaction now here, B, we can see that this now becomes our reactant. And here they use the molecular formula, so not so obvious to look at it, but we can see that we also have this product here that comes out, the potassium bromine, where the bromine that used to be on the molecule is now part of this potassium bromine here. And this is a salt that if you remember your reactions properly, you would see that, or you'd remember that the one where we form this type of a product was called a substitution reaction, particularly hydrolysis, because what we have done here is that we have substituted the bromine. We removed it from this molecule. Remember, it should be part of this molecule. It is now removed and it is swapped. It came here, right? So it is not part of the molecule anymore. So that means we must have put in here another compound in this molecule. And hydrolysis normally would form an alcohol, so this would be an alcohol. I can clearly see here that there's an oxygen missing here. I think I've made a mistake here on this question paper. Please rectify that. There's an oxygen missing here because with a hydrolysis reaction, when you substitute these two, when you swap bromine and what used to be, so what I'm saying is that this used to have a product of potassium hydroxide. it used to have a product of potassium hydroxide. So we took this as a reactant and we added potassium hydroxide into it. And what has happened is that the OH group actually swapped places with the bromine. That's why now we have a bromine here, and here we should include that O, because one of the hydrogens will actually form this hydroxyl group, the water element. That's what basically hydrolysis is all about. We're having water in the reaction, the hydroxyl group. So I think that's what is actually going on in this reaction. And what I've done so far here is what we call problem interpretation. I've actually interpreted what I'm given and, trying to make sense out of it. The next thing that I'll do is that I will match this problem to a topic that we have studied. So I think this problem matches really well with organic chemistry, particularly the section where we study organic reactions, because you can see here already I'm doing, trying to look at different types of reactions. So, and we call that classification when I link my problem to the theories that I know. So, this is problem classification. That's the second rule that we follow. And the third rule would be what we call the A rule, where now I'm going to answer. The A means answer. I'm going to answer my questions because I have a full understanding of what's happening here. I even know where to focus on organic chemistry reactions. So immediately in my mind, I'm switching on the part where I've memorized reactions. So in 4.1, the question says to us that write down the type of reaction represented by A. So obviously we said here we have a hydrohalogenation reaction. So we're going to have a hydrohalogenation reaction. Hydrohalogenation reaction, and this is just 1 mark really. One thing that you have to do with your answer is that you navigate your answer. What navigation means is that you look for errors, check if there are no errors in your answer, and if also it makes sense, right? So for me it makes sense because also I've interpreted this, and that's what I can come up with from that interpretation, and I think everything is okay here. So that is our last rule, the rule of navigation, to say after answering questions we don't just move on. We check if there's no errors, and if everything is right and correctly, verify our answer. And this guarantees us to be sure that we take full marks. Because remember, with the question paper, we are here to collect marks. So that's the game that we are playing here. The next question, 4.2, says explain the answer in question 4.1. So basically here, already we have really answered this when we interpreted. We simply just going to say the reaction involves the addition of the HR, where we're saying obviously the H is a hydrogen, right? So the R here is actually a halogen. In this case, is a bromine. So the R is the same as the bromine here. So we're adding this H. Okay, let me write my H properly. We're adding the H and a a halogen here. So an H atom and a halogen here, and our halogen here, I'm saying it's a bromine, and we're adding that to an alkene, meaning a molecule that has a double bond. Sometimes we can add them to an alkyne, the one that has triple bonds, but in this case we're adding it to an alkene to produce a haloalkane. So we're producing here an alkane, meaning a single bonded molecule that has a halogen in it, right? So if you look at this molecule here, is a single bonded molecule. It's a single bonded molecule. I have 3 carbon atoms, 2, 3, and here I have 2, as I said. So everything here will be single bonded if you draw the structural formula of this. But it also has a bromine in it and a halogen. So we call that the halo alkane. So this also, again, after writing it, you navigate, you check if this makes sense, there are no errors. So you can just literally go through a statement, check if the sentence is well written, there are no any spelling errors and things like that. And then when you are happy with that, you should be sure that it will give you the 2 marks that they actually are giving out here. It should be as easy as that. Then we're going to question 4.3 that says to us that we should define the term hydrolysis reaction. And again, this becomes a very nice question. You should be smiling when you're answering a question paper that is like this, because when we interpreted, we actually talked about this, hydrolysis, hydrogen, and they're asking those questions really. We know that the hydrolysis reaction is actually the substitution reaction. It's part of the substitution reactions. Very important. And this reaction, we're saying that is a substitution reaction that breaks apart. It breaks apart molecules in the presence of water. In the presence of water. And water here, we mean that we actually have the hydroxide. The hydroxide. We are dealing with an hydroxide. So what I'm saying is that we are taking this as a reactant and we are adding a water molecule, and in this case we are using a potassium hydroxide as water, and that would then form again, it will give us an alcohol molecule with some salt there. Those are the results that we get. Excuse me. Now the other thing or the last thing that we do with the question is that we navigate this question. Maybe I can improve here by fixing this so that it is actually written well. We are saying here that this is the presence, in the presence of water. And after checking your answer, navigating your answer, it will give you it will put you in a position where you can be able to take the full marks actually. So that was out of 2 marks. Now when you are happy with that answer and have navigated that answer, we can then now go to the next question that says write down the chemical equation of the reaction represented by B. Now this is an interesting one here because we are required to write down the chemical equation. So basically we just have to write this plus that to produce that. We're writing it down as a reaction. But and it's just here actually, the answer is just here. The thing with it is that they say use structural formula, and they also further request that we write down the major product. We have to give the major product instead. Now to do this is that I'm going to turn this into a structural formula. So that means I'll start off by having a carbon with, or maybe I can have 4 carbons, 1, 2, 3, 4 carbons first. That's the body of my the main parent, the body of my reaction. So let's go back to black pen here. So I'm going to firstly start off by having these 4 carbons, and then now at this stage I can just put in my hydrogen atoms to say we are firstly starting with 3 hydrogen atoms. So that means I'm going to have an H here, and when we look at the second part, we have a hydrogen and a bromine. So I can put the bromine here and the hydrogen here, and we have 2 of this here, so that should be that carbon there, and lastly we have 3 of them there at the end. So this would be that, and we said here we are adding this to a potassium hydroxide. That is a reactant that we're going to add here, because we realize that this is a substitution reaction, hydrolysis reaction. And we realize this because we actually can see that our product is potassium bromine there. Now, this one is an interesting one because that's where we have to do our major product. That's where we have to come up with our major product. Well, one thing that we see here is that we still have the 4 carbons. The number of carbons really wouldn't have changed. Allow me to use this space here to answer this question, because I see that I don't have enough space. Or maybe if I could do the following. If I could write my arrow. No, I don't want my arrow to be small actually, because there's some stuff that I need to put in there. So the product actually here would be a 4 carbon molecule again. And I'm going to only write the bond lines because I have to figure out the major product here. Now, to write this as a major product would mean that if I were to put the hydrogens here and here, we could see that from here going that side, we actually have a lot of hydrogens compared to this side. So this side there's only 3, 1, 2, 3, but this side I have 1, 2, 3, 4, 5, 6. So the majority of hydrogen atoms are on the right hand side. So it means my alcohol should sit here, and this is what we call the major product. Because if I were to put my alcohol here, it means it will be on the side where I have the smallest number of hydrogen atoms, because the largest number of hydrogen atoms, the majority will come this side. So the minority is this side here. So this would be what we call a minor product. So it means my alcohol should actually sit this side where we have a lot of the majority of the hydrogen atoms. And this side is where we have the minority. But to this end, we are also having a product here, KBr, potassium bromine. There is what comes out. Now, the other thing that we have to note about this reaction is that we actually would require to put a little bit of heat. So there will be some form of temperature involved in there. In other words, this reaction, if you can imagine a lab setting where you have a beaker, and basically it means this reaction is a type of reaction where you will put all your products in it and actually put it on a Bunsen burner. You will heat this reaction, and when you do that, you will also add a little bit of what we call ethanol and alcohol, a little bit of ethanol to just to allow the reaction to take place. And those are very, very important elements in this reaction. Always when we do hydrolysis reaction, we include those. We don't just put the potassium hydroxide, but we put a little bit of ethanol and we put this on a Bunsen burner. We heat the reaction and we will be able to form an alcohol molecule and the potassium bromine. Now, this is a substitution reaction because what we actually have done is that we've broken this bond here and also broken these two into potassium and hydroxyl group. And what we have done is that we have substituted the two. The OH actually is sitting now here, and this bromine actually is coming to sit here with the potassium. Then we have the potassium bromide. We have just swapped the two. That's why we say it's a substitution reaction. Now, when you look at this reaction, they give you 4 marks. I think it's really involved, and there's a lot of things that you need to know here. So the first thing that they're going to give you a mark is drawing the structural formula of this given molecule here. And the other mark will come from the fact that you can see that we actually have a potassium hydroxide, because this gave us a clue that it was substituted with this bromine that was sitting there. And the other thing that they're going to give you a mark is drawing this structural formula. So taking the molecular formula here and drawing it as a structural formula. We don't get a mark for this because, we're just writing it the way it is we are given. But the other mark, which is very important, why I said why I need to put a long arrow here is because you have to specify that this reaction there's heat, and then we put a little bit of ethanol there. That will give you 1 mark. And this information is there on your notes or textbook that you are using. So it's just a matter of memorizing these things and making sure that you put all of them in one place. Now, question 4.5, they say to us, write down the base used in question 4.4 reaction. Obviously, we can see that our base here, it is this potassium hydroxide, or what you can call the KOH molecule. So to answer this question is a really quick 1 mark question. Here you are smiling because you are bagging all your marks here. So I will say this is the potassium. It is actually the potassium. Remember K is a potassium hydroxide. It's a water molecule. That is our base. It's then going to give us 1 mark. Again, you can navigate your answer just like in the previous question. You can navigate your answer. Be sure that all your hydrogens are there. You didn't miss any of them, and that will give you a full mark. Full marks for your exam. All the best with your March examinations.